The modern friction loss formula that we use is very simple. It's friction loss is equal to C times Q squared times L. Now the nice advantage of this one is that it takes into account the length of the hose and also C factors for different types of hoses, different sizes of hoses that we use today. When we found that we were getting away from 2.5 inch, we were getting smaller hand lines for an easier attack and getting larger supply lines, we felt it necessary to come up with a better formula. So the constants here are that C is a factor based on the size of hose. For instance, 15.5 is the factor for 1 3/4 hose, which I'll use in this example since it's so common. Q is going to be the flow, but it's also, just like in the old one, it's actually flow divided by 100. And then the next one is L, and that's the length of the hose, but the length of the hose, similar to the old formula, is divided by 100. So for a friction loss, let's say that for our problem we have 200-foot pre-connect of 1 3/4 inch hose flowing 180 gallons per minute. They would want to know what our friction loss is in that pre-connect line. So without factoring in elevation, our friction loss is going to be C Q squared times L. So our friction loss, just plugging in the numbers, our C factor is 15.5 times our Q, which is our flow, 180 gallons per minute, but remember that's divided by 100, so that's going to be 1.8 squared. And then our length, we've got 200 foot, but remember it's length divided by 100, so times 2. So our friction loss, if we multiply this out, is going to be 15.5 times 1.8 squared is 3.24 times 2. Friction loss is equal to 15.5 times 6.48. Friction loss is equal to 100.44. Therefore, our friction loss in this line, without any elevation differences, is going to be 100 psi. So if we had a fog tip nozzle on this where we need 100 psi at the nozzle, then our pump pressure is going to be 100 for the fog plus 100 of friction loss, so we have to be pumping at 200 psi. If it's a smoothbore nozzle, we know that that wants to be at 50 psi, so we're going to be pumping at 150 psi for our discharge pressure. The other thing to remember is that many times this problem is more complex than just one simple calculation. So they'll use wide lines or gated Siamese lines, parallel lines. They'll add in elevation differences that you have to calculate that in. And then along with appliance friction losses. But this is the basic formula we're going to use for each component of that formula.